Hey everybody, I'd like to make a short video to show you how to measure the mass of something if you don't have a scale in order to measure the mass. I happen to have a mass scale in my house, which made it super easy for me to measure the mass of a car. But if I didn't have that, how'd I go about it? Well, on the scale side of things, I can just take this scale here, set the car down on top of it, and it comes directly with a reading. This one happens to measure in both pounds and kilograms, or in grams if I wanted to, which made it really easy for me to just set it on there and say, hey, this car has a mass of 494 grams. But what if I wanted to measure the mass of something without a scale? Well, I have a few tools here that you probably have hanging around your house in order to do that. The first tool is a rubber band, just a regular kind of rubber band that you have going on. I choose one that's relatively large and kind of thin so that it stretches pretty easily as things go. I attached a couple paper clips onto it so that I could attach this to other things easily too. And you'll see why in just a moment. Our understanding here is that if I connect this up to an object here, that it will cause a stretch in my rubber band. And the greater the amount of stretch, the greater the force that's on it, and therefore the greater the mass of the object itself. So if I was to be able to connect stretch of rubber band to object, then I can say, all right, that stretch equates to a particular mass. Well, I need to calibrate this thing first, this kind of mass sensor or force sensor to do so. And in order to do it, I'm going to use a ruler. Now, this ruler I just pulled out of the drawer. It's got inches on one side and centimeters on the other side. I'm going to use the centimeter side here to help me out. And so I'm going to go ahead and take this rubber band and say, well, what if there's nothing hanging on it, like zero amount? So I'm going to put these kind of paper clips up at the top here, and I'm just going to let it dangle like that. Now it dangles kind of an open amount, and I want to leave it dangling with that open amount and set it up next to my ruler here. And if I set this up to next to my ruler and I look at the amount that I've got on the stretch, because there isn't much of a stretch, I get this is a 9 centimeter kind of loop in the end. So 9 centimeters, excellent. That's with nothing. So let's look around the house and see if I can find some other bits that can help us out. One thing is that food products often come with a rating of mass directly on the food product itself. So here's a can of black beans. And this can of black beans right on it actually has a label that tells me how many grams are in the can. So this has 439 grams of black beans in this can here. Now, the packaging itself, does that count in the 439s? Have you ever wondered about whether or not the actual number on here counts the packaging? The answer is it doesn't. And aluminum cans like this, food cans, soup cans, right, actually have a decent amount of mass to them. So I can't neglect that amount. So the whole thing combined is how much? Well, if you go on Google and you search for an empty soup can, you find out that an empty soup can has a mass of about 51 grams. So if I take this amount, which is 439, and I add 51 to that, then I end up getting 490 grams. So this soup can, or this black bean can, with the black beans inside of it, is 490 grams. And what I can do from this is that I can just hang my rubber band directly on my soup can, and I can figure out what the stretch of that is by measuring it with a ruler. And so I can take my ruler here and I can add it to the side and I can look at it and I can get my stretch, right, of my amount, which looks to be about 30.5 approximately. But that's one piece of information. Let's see if I can get some other ones. Looking around my kitchen, I found a few other things. I have a Cliff Bar that we sometimes eat at our house. Cliff Bars have a measurement on them here. This one says that it is 68 grams. And so if I could just attach my rubber band to that one, and the packaging on this one is negligible. It's pretty lightweight stuff. It doesn't matter all that much. So I'm going to take a piece of tape that I had handy. This is duct tape, but you could use kind of a cellophane tape, or you could use masking tape. Any of those would work. And I'll attach it onto here, and I'll let that hang in the same way. And then I need my ruler, and I can measure the stretch of this one. And I can find out that the stretch of this one appears to be closer to 11.5 as we go. And I can walk through the same process on other items, like my cell phone. If I look up online how many grams my cell phone is, it'll tell me that it's 175, 176 grams for my cell phone. So I could hang all of these bits along the way. I could then also hang the car that I'm trying to find the amount of. Right, so I've got a car here, right? This is the one that you see in the screen over there. And if I was to hang my rubber band from that instead, I could find out what the stretch is for the car. Now, this is pretty difficult. I haven't written anything down yet. We probably should write some of these numbers down. And in order to write some of these numbers down, in a moment, I'm going to use a Google Sheets because it's going to be helpful along the way. So I hang my car from this. Good. And I get a particular stretch. And I can go from there. All right, so I've got all of my information of my things that have numbers written on them, and then one thing that doesn't. So let me go across to my Google Sheets here. And I've already entered in some of this data so that it's a little faster for us to do our work. Where I now have kind of my empty rubber bands, which had a kind of a stretch of 9.2 when I was doing it more accurately. And there's no mass that's hanging from it, so I called it 0. My soup can itself, putting in the empty soup can as well, gives me 490, and the stretch is 31.5. My cell phone gave a stretch of closer actually to 14. Cliff Bar 11.4, and each of those masses is here on the side. And here's my car, and I don't know what this number is. I need to figure that out. So notice that it is darn close to the soup can. To be perfectly honest, the soup can is slightly more than the car. So that means that the car is pretty close to 490 grams. And right now, if you didn't do anything else, if you were able to find an item that gave you the exact same stretch as the car itself, you can recognize that that stretch is going to give you a really close, kind of connection. Mine says 494. Right. And then my soup can, if you look over here, is 490. That's like a difference of 4 grams. That's really close. But what if you weren't able to find an item that's so close, right, as it goes? In this case, I could just say, well, it's really close to 490. It's about 4, probably a little bit less than 490, according to kind of my items that I have here. Well, one thing I can do is I can go ahead and create a table turned into a chart. So I'm going to highlight these items on there, and I'm going to say insert chart or graph. Now this will probably show up behind my picture, so I'm hoping I can do this in a meaningful way. Let me go ahead and make this a little bit smaller, drag it over here a little bit. All right, good. Right now I've got a number of different data points that are on here. I've got my empty, I've got my cell phone or Cliff Bar, my cell phone, and then the soup can up here. Turns out that I can create a nice tool here, which is a trend line. So if I click on this, and it comes up with some information over here on the side, I can go to customize. This is just a scatter plot here. And I can go down to series, and I can click on trend line, and it will draw the best fit line through my data. Now, it's not perfect because it's hard to measure on a ruler with a rubber band. And if I could, it would be better. I could also come down a little bit further and say label, and I could turn on a custom label here, or I'm going to use an equation as my label. And that's going to put my equation for this best fit line. Now, that this equation for the best fit line right here is in the form of mass is equal to this number 21.1 times the length, which is my x, plus a negative 165. And if I was able to just plug in a stretch here for any given item, I can find out the mass of that item, which is pretty cool using that one rubber band. So I'm going to go ahead and do that here using a calculator to help me out. I'm going to use Excel or Google Sheets as my calculator. So I've got 21.1. I use that equal sign beforehand so I know I'm doing my math. And then I'm going to multiply that times the stretch from my car. And the stretch from my car, oh, let's see if I can find that. I want to move that down. Oh, it's 31. So let's get that out of there. So my stretch was 31 for my car. I can barely see it underneath the screen. There it is. And then I'm going to subtract from that 165. So 21.5, 21.1 times the stretch times 165. And what I get is I get a number of 489.1. 489.1. Is that close to my actual mass itself? Well, if I go back over here for a moment, you'll see that I have 494. It is darn close. It's not exactly close, perfect, but 494 and 489 is a separation there of really like about 5 grams, and 5 grams is about 5 paper clips. It's not a heck of a lot. It's darn close to what we've got, and it's close enough for this particular project. So that being the case, I went ahead, and if I had wanted to stop with the soup can, I could, because it was close enough in this side of things. I can get even closer by doing a best fit line here, and then recognizing that I've got an equation where I can just plug in anything I want for this X, which is the stretch of my rubber band, and I can figure out the mass of anything as long as it stretches the rubber band some. So, ladies and gentlemen, I hope that helped. I'm going to stop this video, and if you've got questions, please do stop by and see me during office hours, and we'll talk to you then. All right, take care. Bye-bye.